Hi everyone. In this video, we're going to talk about how to find the horizontal asymptote of a rational function and also how to find the y-intercept of a rational function. But let's start with the horizontal asymptote. So the horizontal asymptote is the value that y approaches as x approaches positive infinity or negative infinity, which basically is the end behavior of the function. Okay, recall that the end behavior of a polynomial is determined by the degree and the leading coefficient. So remember, we learned that if the degree of the polynomial is even, both ends are up, or both ends are down. And if the degree of the polynomial is odd, the ends go in opposite directions. So since a rational function is the quotient of two polynomials, you can determine the end behavior by dividing the leading terms. All right, so let's do that. Let's look at our first example. So these are the leading terms of the polynomials. So if we take 3x and divide it by 2x, x divided by x equals 1. So this just simplifies to 3 over 2, which means as x approaches positive or negative infinity, y is approaching 3 over 2. So with rational functions, if the graph has a horizontal asymptote, then y approaches that finite value. Versus with the polynomials, y would always approach positive or negative infinity. All right, so if y is approaching 3 over 2, that means the horizontal asymptote is y equals 3 over 2. All right, let's look at the next example. So again, just divide the leading terms. So we have x divided by x squared. Well, that simplifies to 1 over x. Now, if you recall, 1 over x is our parent function, which, remember, the graph looks like this. And so as x approaches negative infinity, y approaches 0. And as x approaches infinity, y approaches 0. So in this case, we would say, as x approaches positive or negative infinity, y approaches 0. Which means the horizontal asymptote is y equals 0. Actually, just like the parent functions. Okay, let's look at the third example. So our leading terms, we would have 2x to the fourth divided by x cubed. Well, that would just simplify equal to 2x. Well, 2x is a linear function with slope of 2, so maybe it looks something like that. So as x approaches positive or negative infinity, in this case, left and right end, y is approaching positive or negative infinity. So in this case, because y is approaching positive or negative infinity, there is no horizontal asymptote for the rational function. Because when there is a horizontal asymptote, y is going to approach a finite number like we saw in the first two examples. Okay, now there's a shortcut to this. So all you actually have to do is to determine the horizontal asymptote of the rational function is compare the degrees of the polynomials. Okay, so the way this is written, n is the degree of the numerator, m is the degree of the denominator. So if n is less than m, which would mean the degree of the denominator is bigger, that's what we saw here in example 2, that's when the horizontal asymptote is y equals 0. If n equals m, which means the degrees are the same, that's what we saw in example 1, then notice the horizontal asymptote comes from the quotient of the leading coefficients. Because our HA was y equals 3 over 2. So A and B are the leading coefficients. So your HA would just be y equals A divided by B. And if n is greater than m, which means the degree of the numerator is bigger, that's when there is no horizontal asymptote, which is what we saw happen in the third example. Okay, let's look at a couple more examples. This time we're going to use the shortcuts because you can just look at these and tell what the horizontal asymptote is. Okay, let's look at the first one. Again, compare the degrees. The degree of the numerator is 2. The degree of the denominator is 2. Since the degrees are the same, all you do is divide the leading coefficients. 3 divided by 1 equals 3. So the horizontal asymptote is y equals 3. All right, in the second example, the degree of the numerator is 1. The degree of the denominator is 2. Since the degree of the denominator is bigger, the horizontal asymptote is y equals 0. That's all you got to do. Okay, next we're going to talk about the y-intercept of the rational function. Now recall that the y-intercept of a polynomial is the constant of the equation. So for a rational function, since we're dividing two polynomials, you just divide the constant terms. So in this case, if we divide the constant terms, we get 2 over 4, which simplifies to equal 1/2. So the coordinates of the y-intercept would be 0, 1/2. So that's all you have to do, just divide the constants, and you'll have your y-intercept. All right, you guys, we will practice this in class. As always, thank you for watching.